Day 3 warm-up and notes. These first two questions are the warm-up, so I suggest you press pause, try these problems on your own, and then check your answer with me. One thing to point out, where it says AROC right here, that stands for average rate of change. All right, it's just a shortcut way of writing it, and you guys know average rate of change is really just slope. So feel free to press pause right now, and then press play once you've done the problem and you want to check your answer. So let's go over number 1, find the average rate of change or slope between x equals 1 and x equals 2. So remember, slope is just y2 minus y1 over x2 minus x1. You need 2 points. They gave us x values, but there's no y to go with these. So I think that's why we have this graph of g of x, so we can find these points. All right, this point 1, 1. And then if we go over 2, up 4, the other point is 2, 4. So this could be our x1, y1, x2, y2, and we could plug those numbers in. We'd have 4 minus 1 over 2 minus 1. We'd get 3 over 1, or 3. That is your average rate of change or slope, or in other words, AROC. All right, let's look at the next question. Same thing, find the average rate of change between 0 and 1. So again, I would write the points out, 0 comma something and 1 comma something. So it looks like 0, 0, and then 1, 1, and we have to find the slope there. So we could do y2 minus y1 over x2 minus x1. Always label your points. It just helps you to not make mistakes. All right, so we'd have 1 minus 0 over 1 minus 0, which would get 1 over 1, or 1. So 1 is your answer. All right, and of course I chose this, slope formula right here. You also could have done rise over run and just counted for each of these. If these were your 2 points right here, you could have said I'm going up 1 over 1. My rise over run is 1 over 1, which also equals 1. You get the same answer either way. So it's really up to you. When you do have a graph in front of you where you can easily count, rise over run is an option. If you didn't have a picture of the graph and it was more difficult to count, that's when you'd want to use this y2 minus y1 over x2 minus x1. But it really doesn't matter which method you choose. We're going to be talking about linear functions. So the main thing you got to know about a linear function is that the graph is a line. And if you ever forget that, think about in the word linear, first 4 letters spell out the word line. So graph is a line. All right, and we say that it has a constant rate of change. Or in other words, you guys know rate of change, average rate of change, is really just slope. All right, so really what that means, a constant rate of change or a constant slope means no matter what 2 points you pick on the line, you will always get the same slope. So to make this a little bit easier, let's label these points A, B, C, this can be D, and E. All right, it should not matter what 2 points you pick. Say you choose points A and D. All right, if we were to find the slope, let's do rise over run between A and D. We'd go up 1, 2, 3, 4, 5, 6 over 1, 2, 3. That's up 6 over 3. And we get a slope of 2. All right, again, it shouldn't matter what 2 points you choose. Let's say now we chose the 2 points B and C. If we did our rise over run and found our slope there, we'd go up 1, 2 over 1, up 2 over 1. Divide that out, you get 2. You get the same slope every time. So maybe clarify for yourself, constant rate of change or slope really just means it's the same slope no matter which 2 points you use. All right. Next, we got to talk about slope-intercept form. All right, which I think you guys have heard of before. That's really just your y equals mx plus b. So you guys have known this for a while. We just got to review it. I think you guys know the m represents slope and the b represents your y-intercept. And one thing to point out, your y-intercept, if you're ever talking about a word problem, you could also think of the y-intercept as the initial value, kind of the starting value of something. And we'll do some examples with that. All right, so let's take a look at example 1. It says determine whether the function is linear or not. So you're given a table of values, just a bunch of points, 4 different points, and we have to figure out if it's linear or not. So remember what really linear is. Linear means there's a constant rate of change or slope. No matter what 2 points you pick, you have the same slope. So I would just check the slopes. I would pick pairs of points like these 2 points. Let's find the slope between them. And let's do that for a few different points to see if they have the same slope or different slopes. And I think that will help us figure out, is the function linear? Would the graph be a line or no? So let's use our slope formula. I would use y2 minus y1 over x2 minus x1. Since we don't have an actual picture of the graph, it would be hard to use rise over run. All right, so think this is our y2. Do 6 minus our y1, which is 2, all over our x2 minus our x1. If we do that math, we get 4/5 as our slope. All right, let's do another pair of points. Let's say these 2 points will find the slope. Probably don't have to write the formula out again. It'd be 10 minus 6 over 15 minus 10. You'd get 4/5. We do have the same slope. I would make sure you check all the pairs of points. Sometimes they could trick you, and the last one could be a different number. So let's take this last pair of points and find the slope. 14 minus 10, all over 20 minus 15. You get 4/5. All right, so we got 4/5 every time. We got the same slope. So we can say, yes, this is a linear function. If we were to graph these points, we could connect them with a straight line. All right, if you were to get different numbers, say you got 4/5, 4/5, and 3/5, you would have to say, no, it is not a linear function. All right, let's take a look at example 2. A divvy bike in Chicago can be represented by the formula C of t equals 7 plus 2t, where C of t represents the cost in dollars and t represents the time rented in hours. So I'm not sure if you guys have seen these divvy bikes. They're those blue bikes that are, on random street corners in Chicago, and you can kind of pick them up, ride them, and drop them off at another station to kind of get around. So it says, what is the slope? So if we take a look at that formula, think about what your slope would be, 7 plus 2t. All right. The formula is kind of written in an odd order. I feel like we're used to y equals mx plus b, where kind of the slope comes first. But if you wanted to, you could rearrange it 2t plus 7. All right. I like to think the number in front of the variable is always going to be your slope. All right. So your slope is going to be 2. And then it says interpret the meaning of the slope. We have to understand what this actually means, this number 2. All right, and I wouldn't just take a guess at it. Usually I have kind of a system that I use to help me figure out what the slope is. So first of all, I always like to make the slope a fraction. If it's not a fraction, make it a fraction. You could put it over 1. And then think about what your slope formula is. We didn't have to use the formula. We just kind of pulled it from the equation. All right, but your slope formula is y2 minus y1 over x2 minus x1. All right, so in this problem, your x's, your x, and it won't let me highlight that, so let me use a different pen. Your x is really a t. All right, so your x's down here, those are really your t values. T says it's represented in time in hours. All right, so t is in hours. All right, and then your y value, all right, your y is really your c of t. And they said C of t represents cost in dollars. So this is really kind of like C of T, and those are costs in dollars. So that's kind of how I kind of think it through. And I think, okay, this 2 represents $2 and this 1 represents 1 hour. So what that means is $2 for every 1 hour. So think if you're renting a bike, it means it's going to cost you $2 for every 1 hour that you rent that bike. So interpret the meaning. When they say interpret, once you actually figure out the meaning, you should write it in a complete sentence. So you should say, to rent a divvy bike, it costs $2 for every 1 hour, something like that. All right. When you're interpreting slope, you want to be sure to mention both numbers, your numerator and the denominator. Make sure you represent or make sure you mention the units too. If you say it costs 2 for every 1 hour, what does that mean? $2, $200, 2 cents. All right. So just make sure you're really being specific and using those units. All right. Then it says, what is the y-intercept? So the y-intercept, that's your 7. All right. Usually I like to write it as an actual point. So you guys know, an actual point is an x comma y. All right. The y-intercept is 7. So we know the y is 7. All right. The x is always 0. All right. If you think about the y-intercept on a graph, you always go straight up the y-axis. The x is always 0. So to interpret the meaning, I use this point, all right, to help me. Again, I go back to, my x's are really t's. Those are in hours. So this 0 represents 0 hours. All right, and my y's, those were my C of t's. Those were in dollars. This represents $7. All right, so really the meaning of that is if you rent this bike for 0 hours, it's going to cost you $7, which that might be confusing. Think about if you rent it for 0 hours, you don't rent it at all. Why do you have to pay $7? Well, that's probably the rental fee. Everyone has to pay $7 to just get the bike, and then you have to pay, that $2 an hour for every hour you have it. So that's kind of the base fee. So you can write it however you want. Probably the easiest way, if you use this point, you can say, if a bike is rented for 0 hours, then it costs something like $7. You could write it like that, or you could write something that makes a little bit more sense. It's up to you. You could say, the base fee to rent a bike is $7, something like that. So we could say, or the base fee to rent a bike is $7, something like that. Really, either is fine. However you want, you can write it as long as it makes sense. Let's take a look at example 3. $1,200 in 2008 is depreciating at a rate of $2,500 per year. So if you're not sure what depreciating means, that means the value is going down every year. All right. So it says, write a formula for the value V of the car T years after 2008. So if we have to write a formula, it's kind of hard to write with the right variables. They're asking for T and V. I would just use the standard, X and Y, and then kind of swap them out at the end to have the variables they ask for. All right, so let's think about this. This is going to be a linear equation. All right, so let's think about, Y equals mx plus b. Right, we've got our two numbers. A car that cost this in 2008 is depreciating at $2,500 per year. All right, so we said on the previous page that in a word problem, your y-intercept could be your initial value. This 21,200, all right, to me, that's the initial value. Maybe this person bought this car used in 2008. Maybe they bought it new, all right? But that's kind of the initial value that this person had for the car, 21,200. All right, so that's going to be your y-intercept. All right, and then depreciating at a rate of $2,500 per year. Every year, that car goes down the value $2,500. And that's going to be your slope. So that's the slope. All right, so we could just plug those in. You guys know slope is m, y-intercept is b. All right, the slope, though, since it's depreciating, going down, you need to make it negative 2,500. All right, if the value was going up, you'd make it positive. So that's something to kind of look out for. They're not always going to tell you about the negative, but you have to take hints from the problem. So negative 2,500x plus our initial value was 21,200. All right, that's really the formula, but again, we need to kind of swap out the letters. All right, they asked us for the value V of the car, T years after 2008. All right, so think about which is which. All right, what's our X, what's our Y? You could think about independent and dependent variables here. X is the independent, it influences the other variable. So I think T, the time in years, that'll be the independent variable. That's going to influence the value of the car, right? The longer you own the car, say the car is 10 years old, 20 years old, 30 years old, all right, that's going to influence your value. So we can swap out our letters. All right, instead of a Y, we're going to put a V, negative 2,500 instead of an X. We will put a T plus 21,200. And that's what they're looking for. Write a formula for the value of the car. T years after 2008, that means we could plug in any year, after 2008. Say we want to know what the value would be 1 year later, 2 years later, 10 years later. Plug that number in for T, and we can figure out what that value is. All right, so in part B, how much is the car worth in 2016? Well, remember 2008 was kind of the beginning year. All right, up here, so think how much later is 2016? That's 8 years later, so that would be T equals 8 years. So we could just plug in 8 for our T. So we could do V equals negative 2,500 times 8 plus 21,200. All right, and we could do that math. Feel free to pull out a calculator and type that in. Negative 2,500 times 8 gets you negative 20,000 plus 21,200. And if you do that math, you get 1,200. All right, that's your value of the car. We're talking in dollars. All right, that means, 8 years later, a car is worth 1,200. Probably, 8 years later, it's had a lot of wear and tear. It's probably not worth much. All right, I hope you guys found these notes helpful. If you have questions, please contact your teacher. Otherwise, you can get started on the homework.